Hello, everyone. Is everyone able to hear me well? Okay, so we are about to start, and I really appreciate all of you joining into the webinar on hardware hacking with Joe Grant. Okay. Yeah, and I hope you're able to see me now as well. We're just waiting for. Hey,
No.
so yeah, good to.
Does this sound okay?
Yeah, this sounds perfect. Yeah.
Cool.
Yeah.
Sorry I'm late.
Oh, no worries at all. So yeah, so welcome, Joe, and I really appreciate you making the time for this webinar.
Yeah, thanks for having me. This is sounds like it's gonna be a lot of fun. So as always,
Yeah,
I'm running behind. I'm sweaty. I was just out for a run, dropping my kids off at school, and it's just like the daily routine of trying to do as much as possible. So
yeah,
if you're wondering why I'm dripping sweat, it's not because I'm nervous. I'm just hot.
yeah, and you're like doing so many things like at the same time. It's tough. Yeah,
Yeah, it's sort of like I don't remember where I learned it, but I feel like I've always wanted to just keep a lot of plates spinning, like just
uh,
doing a lot of stuff. If I'm bored, I'm sort of like, I don't know what to do. So I'd rather have too much stuff and just, like I like checking things off lists. So I just try to do as much as I can, which sometimes is hard, and
yeah,
sometimes it takes, longer to do one thing than another because things stack up. But I like to be busy, and yeah, so lots of different projects, lots of stuff, and it's, whatever I think is fun, basically.
yeah, perfect. So yeah, we'll get into all of that, all of the things that you have been working on, some of the things you have done in the past. So yeah, so just to start this webinar, hello everyone. My name is Aditya. I run this security firm called Attify, where we specialize in IoT security and training. We also have a store called Attify Store, where we offer a lot of different training solutions as well as different products for IoT security assessment. And in this webinar with me is the one of the most popular hardware hacking guys you would ever get to know. So Joe Grant, Joe Grant, welcome again to the webinar. And you have
Thank you.
been, yeah, you have been involved in hardware since I guess like close to 20, 25 years now.
Yeah, let's see. Since 1982, when I was 7 years old, I got involved in electronics and in computers, which at the time was like, people didn't, not everybody had computers, so you had to be
Right.
really lucky to have one. And I had an older brother, and just fell in love with electronics and computers that early. And it's like most kids when they're younger, they think they're going to be an astronaut or a firefighter or a policeman. Like I knew I wanted to be an engineer, and that's just from then. So yeah, it's been quite a while.
Yeah, and how did all of that start? Like, how did you first get involved in electronics, or what was kind of the turning point where you decided that this is what I want to do for the rest of my life?
Yeah, so my brother was into computers, so he really was controlling the Atari 400, which is what we had. He was also into electronics, so he had a bunch of electronics magazines, popular electronics or radio electronics, whatever it was called at the time.
Uh-huh.
And he also liked repairing, audio equipment. He was a musician, so he had this junk bin full of circuit boards and stuff. And I would, do favors for him, do his chores or whatever in the house, and he would let me pick a circuit from his box. So
Yeah.
he was like this inspiration, which is funny because I don't even think he knows how much of an inspiration he was. But it was those little things of like I was collecting circuitry, and then he showed me how to make my own circuit board. So I, etched my own circuit board when I was probably, I think 10 was my first circuit board that I etched, and I'd been building projects before then, just soldering things together. But I just started building things out of magazines early on, and then realized, okay, I could build this. What if I change this around? How's that going to work? And I think that just sort of coupled with my mindset, even when I was that little, of like I like pushing people's buttons, I like questioning things, I like sort of being not really not aggressive isn't the right word, but I like questioning things. And
Right.
I think that that mindset coupled with electronics being so cool and computers, of course, just sort of drove me that way. And at the same time, he introduced me to bulletin board systems. So we had an
Uh-huh.
acoustic coupler modem that we would like, rotary dial phone, put the
Yeah.
modem, put the phone handle on the modem, and and call bulletin board systems. And of course, then like everybody else back in the day, you wanted to branch out past your local bulletin board scene. So we had to
Right.
call long distance phone numbers, and I paid one phone bill, and it was really expensive as like a 9-year-old or whatever it was. My parents made me pay, and then he had actually sort of not intentionally showed me how to make free phone calls, because I discovered a code written on the back of one of his old floppy disk numbers. It was an 800 number with a 6-digit code. And that's how I learned that you could make free phone calls, and, discovered the underground sort of hacker world, the subset of bulletin board systems. So instead of trading games, it was like, trading codes and credit card information and phone numbers and like everything. I would just collect whatever I could. I wouldn't necessarily use it all, but it was just like, something fun. So it was exciting, right? Like as a kid, you have these superpowers. Like nobody was doing that, and I could, call crazy computer systems, and nobody understood what I was doing, and like that was really fascinating.
Exactly. And at that point of time, it must have been like a lot of information overload. Like there's so many things out there and I have to learn all of this, right?
Well, think about it as like, IoT devices now, right? Like everybody just connects things to a network, and you can like run Shodan and see what's out there. And it's like everything's completely exposed, default passwords, all of that stuff. It was the same thing, except we're using modems and connecting the bulletin board systems and connecting to other computer systems that had no passwords or weak passwords, or somehow, we went through the trash of the organization and found the passwords printed out. So it's really like, there's not a lot of difference. It's just a different technology, but it's the same thought process. And that's sort of actually what's scary, right?
Yeah. And I really like the fact that you brought up that instead of just accepting how things are, you have to be really curious about why is it exactly happening this way, and trying to understand how it works in order to become like an expert at something, right?
Yeah, that's the thing, is you really want to be curious. And that's something that I've always, ever since I started giving talks, like that's the thing that really excites me, is like getting people to think a different way, or inspire them to say, oh, I don't have to take, this device and just treat it like that. Like how does it work? Why doesn't it work? How do I fix it? How can I take it apart? How can I learn from it? So it's just all of these like, things that a lot of people, especially nowadays, they just take a piece of hardware for granted. They take a piece of technology, computer, whatever. And I feel like that is just something that is so satisfying to like share that stuff. And it's been like that since I was a kid, because I would trade information with other people and learn something new. And then, I would teach somebody something and they would teach me something, whether it was in person at like a, 2600 meeting, or at our old hacker meetings in Boston, or whatever it was. It was always this information sharing.
Yeah, and that's exactly how a community also grows, right? You have to be willing to share information with other people. Yeah. So going back to your early days, you were an early and like one of the first members of Loft, right? So
So yes, that's a common question. So the Loft had been around for a few years before I joined, and the Loft was a group of hackers in Boston. There's a lot of history about us online. That's mostly true, sort of the beginnings of the Loft and everything. With time, history, memory sort of fades. But generally, a bunch of Boston area hackers needed a place to store equipment, and it just became this kind of informal clubhouse. Over time, it morphed into something more formal. Like when we testified in front of the Senate in 1998, there was 7 of us, and we had been there all together for a few years at that point. But in 1992, when I joined, it had been around maybe I think a year or two, and we had all been associated with each other because it was the Boston hacker community. But those guys were like, yeah, we like Joe, he's all right, but he's still a little young, causing a little bit too much trouble. Like, let's let him get that out of his system and then join. And they were totally right, because I ended up, I joined in 92. I can't remember how old I was. Can't do the math. But I was definitely early on, but I had gotten arrested for some things back around, or a little earlier than that. So they were right. Like, I had to get it out of my system. There's actually a talk I gave at CypherCon a few weeks ago that was recorded, called Hacking, Freaking, and Juvenile Delinquency, that talks about all of my juvenile delinquent past, and phone freaking and breaking into things physically and otherwise, and like that whole story. So if people are interested in like the details of why I got in trouble and the path that got me there, that video should be released soon. But yeah, so I got in trouble, and then after that, they're like, all right, now let's bring them in. And the Loft guys ended up being, they were 6 years older than me, all of them at least. So they ended up being mentors. And I guess I was 16 when I joined. The other guys were, much older. At least it seemed much older at the time. And I was just like this young, punk, whatever, skateboarding, mischievous kid. And that really was like this resource for me to go after school. I could go there. And I would actually bring friends of mine there that weren't into technology, but we would like skateboard and cause trouble and whatever. And then we would go there as like our sort of refuge. So it was really a special place to kind of grow and learn, but keep me out of trouble. And, you know, that was like the best path for me to take. And then over time I started, you know, contributing, but it was like, at first it was really a lot of learning from, you know, almost mimicking what the older guys were doing, as far as like learning the importance of how to share information and go to conferences and do what you like to do and be curious. And it just justified what I'd been doing early on, but realized that I could, you know, use that power for good instead of for malicious purposes.
Right. And do you think it's really important to actually have that sort of a mentorship community or someone to actually look up to who can guide you for your starting journey? Like, how important do you think it is?
I think it's pretty important. I mean, back then there weren't really resources for hackers getting together. Like, you know, the Loft was one of the first, if not the first, publicly facing hacker group. There had been hacker groups before then that were focused on breaking into systems, where we were focused on exploring technology and sharing with the world and kind of letting the mass people, the mainstream, know what hackers were about, sort of the good side. So there were no resources. Like nowadays, you know, with hacker spaces and maker spaces and Maker Faire and all of the hacker conferences, there are so many resources, and I think it's really important, if not a direct mentorship, at least learning from work that other people have done. And I think that's something that we forget in the InfoSec world a lot of times, is like, we're all standing on the shoulders of somebody else. Right? It's like when you come out with an O-Day or you come out with some cool exploit, you didn't just create that in some magic vacuum. Like, you know, there's decades of work before you that have sort of built on that. So even just that mentorship of like learning from history and reading the past advisories and kind of repeating what somebody else had done and then maybe build on it. Like, I think that's really important. Realizing that we're all, you know, we're all in this community, but nobody is this crazy, you know, rock star that's smarter or better than anybody else. You know, it's just like some people are more in the forefront, some people are more in the background, but we all love what we do. And, you know, finding other people that think that same way, I think is really important.
Yeah, exactly. And I think it's one of the best time to ever get started into all of this security industry, or like hardware hacking, or be like any other aspect of hacking, because there are so many resources available online. You've got like all the presentations, all the advisories, everything to learn from. Yeah.
Yeah, I mean, it's great. It's really great.
Yeah. And so moving back like to the Loft story. So you were 22 when the US Senate thing happened. So how was that experience? Because being 22 and like actually getting to testify against the, like in front of the US Senate would be like I don't know, scary.
That was
Morning. My name is KINGPIN. I am the youngest member of the Loft and one of the electrical engineers and hardware hackers. While some of the Loft members concentrate on software programming, I work with hardware design and implementation of electronic circuits. My interests include embedded system design, surveillance and counter-surveillance tools, and wireless data transmissions. My current research project involves experimentation with the monitoring and eavesdropping of stray electromagnetic fields from computer terminals, otherwise known as tempest monitoring. Using low-cost electronic equipment, one can capture the contents of computer screens from more than 200 meters away, possibly gaining passwords and other sensitive information. The phenomenon of tempest monitoring has been known to the industry for decades, but there is not much unclassified information available on how to both capture the emissions and also protect oneself from becoming an eavesdropping victim. My research will not only help me learn about the monitoring technology, it will enable me to educate others to help them protect their computer systems from prying eyes.
It was somewhat terrifying, but at the time I didn't really know the importance of that, like how special that was. I was just proud to be with this group of guys and go and like, you know, be hackers and get to talk to people. And it sort of was like talking to your grandparents or something. Like, it was such a disconnect between, you know, what we were doing and what the government was aware of. But yeah, I was scared because that was actually one of my first public speaking engagements ever. And I had to wear a suit, which is like completely off, like, if you want to make me uncomfortable, put me in a suit. That's pretty much. So we got there, and there was, cameras everywhere, and it was a real kind of circus, media circus. But I just didn't realize the impact of that, for quite a while, actually, until probably like a year or two ago when people are still talking about it. But it was an interesting time to share what the hacker view, right? Like the hacker view of the world with that really had no idea about that world at all.
Right. During that time, did you ever felt like hacking or the entire security research is going to be one of the most mainstream things that people are considering doing, like in 10, 15 years, right?
No idea. It was something where we were just doing what we like to do, and we got invited to talk about the worst case situations that could happen on the internet at the time in 1998. Where like not even a lot of people were on the internet at that time. It was sort of becoming a thing.
Right.
And I was a hardware guy. I'd always been a hardware guy. Brian Oblivion was our other hardware guy who did a lot of radio, wireless, satellite stuff. And we were always I considered like we were always kind of a black sheep in this industry because we were doing hardware and electronics, but really people only cared about the network side and
Right.
apps and whatever, right? So we were always kind of on this subset. But I could have never imagined that the industry would become what it was in general,
Right.
but then also that hardware finally
Yeah.
has become something where people go, oh, we can connect these things to our network, and like just because they have blinky lights doesn't mean they're not secure. It's sort of this like awakening of people over the past few years. And I guess things sometimes move slower than we expect them to. And
Yeah.
in the hacker world, in the technology world, things move super fast. But I guess in the real world, it takes a lot longer for things to actually get realized. The downside is if what we had talked about then had been acted on faster, we might not have some of the same issues. But it's a hard problem because you have all these different people designing pieces of electronics and hardware devices and designing whatever web front ends and all these things that are just all vulnerable because
Right.
you just can't teach people fast enough, right? It's like
Yep.
too many people are getting involved before you can teach them the right way to do things, and doing things the right way is much easier said than done.
Yeah, exactly. So the whole hardware hacking thing, if you look at now, I think that also became like one of the mainstream things because of IoT getting popular, right? And it's kind of the same embedded devices or the same hardware security issues which are in the devices part of this the entire IoT ecosystem. So I think IoT in one of the ways actually helped the hardware security scene to or getting the manufacturers actually aware that hardware is insecure unless you actually protect it.
Yeah, my sort of view is that, and this is from experience of seeing a lot of the Loft guys doing software advisories and things. Like you can only teach engineers so much, and I think it's not reasonable to expect every engineer who's designing products to understand security, because those of us who are in security can barely understand security. Like there's so much to it, and there's so much that can go wrong. And even like in theory, things like secure boot process and code signing and all these things make great sense, but when you try to actually implement them, there's so much complexity. So I think and sort of my new thing has been like, well, the vendors are larger, they have more of a reach to the individual engineers. It would be great if they can put more resources into, in their reference designs, in their sample code, in their documentation, things that engineers are going to use and just use as building blocks. Like make those more secure and understand that people could break their product. So it's less about the product vendor and more about the vendor of the chips and the vendor of the modules that people are using in their products. Because if, the easier it is for an engineer to implement, say, crypto, the more likely they're going to use it, and the more likely they'll use it correctly. So if the vendor does it right, then the engineer will do it right.
Yes, exactly.
Yeah, exactly. It trickles down.
Yeah, true. Also, like one of the very early things, like one of the major contributions that is credited to you is making the electronic badges popular. And at this point of time, where we have like electronic badges being like sort of normal in all the security conferences around the world, when you started, it was sort of a new idea, right?
Yeah. So I don't have any of them here. I should have grabbed some, but. As far as we know, the DEF CON badges I did for DEF CON from starting at DEF CON 14 was the first instance of an electronic badge at a conference. There probably is somebody that did it beforehand, right? Just like there's always somebody that does something. But as far as the hacker community, that's what we know. If somebody has, a link or something to older, that would be even better to show that progression of, again, standing on the shoulders of other people. But yeah, as far as we know, that was something where there were no other electronic badges. There were no hardware hacking villages. It was just a different time because more people were focused on the network side, and it was sort of new. The way that came about is I teach a hardware hacking class. Actually, I teach a few different hardware hacking classes, but the main one is this 2-day class on, just kind of the whole process of hardware hacking and reverse engineering boards from a board level, so identifying components, figuring out the interfaces, connecting, all sorts of stuff, soldering, desoldering. And I have a circuit board I use for that. That's a custom circuit board. It's in the shape of my logo, little G-shaped logo. And I had been training at Black Hat. I started in 2005, and Jeff Moss, the Dark Tangent, who was running Black Hat at the time, who started Black Hat, also runs DEF CON. And I had known him for years, since we were a teenager. And he saw that badge from the training class and said, "Hey, we should do something like that for DEF CON." So it was totally his idea, because DEF CON has always been known for interesting badges of whatever they're made of, whatever material and stuff. But yeah, it was totally Jeff's idea to take my little custom board that a handful of people got to see in every class and say, let's do this for the conference. And that was the beginning. So DEF CON 14 was just like a little round circuit board with the I don't know what he's called, the pirate skull crossbones thing with happy face. Few LEDs and a microchip PIC. It was a PIC 10F something. It was a SOP 23, really tiny microcontroller, blinking lights in different patterns. And then I had a little hardware hacking, badge hacking contest that was just held I think it was in the vendor area. So it wasn't even like a formal contest thing. It was like, come to the vendor area, hang out, hack on your thing, learn how to connect up the debug tools and use it. And it started off very small. And then over time, it sort of ramped up.
Badge in the first year?
Yeah, I think we had I think we made 6,000 badges the first year, and like 20 people did the badge hacking contest, which is pretty small. And even by the time I did DEF CON 18, so by that time, just within a span of 5 years, it had already become, making electronic badges had started to become a thing. Just within DEF CON, different parties would make them and things. And then after that, it just exploded into the whole badge life phenomenon, which I think is great. I think it shows that there's interest in hardware. It shows that that being able to develop hardware, the resources to do it are more available, which they are. And it's something that gets people excited. And I think hardware seems to be, even with hacking IoT stuff or designing badges or whatever, it's a new frontier for a lot of people that have, grown up just doing software stuff, typing on a keyboard. Now they can do something physical. So it's exciting to sort of branch out. From my perspective, the reason I stopped designing badges is mostly just my personality. I had done the 5 years and progressively every year trying to do something different with some new technology and some new neat artwork. But I sort of got tired of trying to compete with myself. And then by the time badges became so commonplace, I was like, all right, well, I don't want to do that. Like, now everybody else is doing it. I want to try to do something different. So I just sort of stopped. And then being that thing of like everybody was expecting me to do it, I'm like, I'll just stop. And, it needs some new blood. Somebody else should do it and just see what happens. Because, I don't want it to stagnate of like, Joe is the guy that does the badges or whatever. So it became, more of a community thing, and then Loft took it over, and I think some other people are doing it. And of course at, every conference and every party, people are doing badges, and it's this whole kind of sub community. So it's wild to see, and I love seeing it grow. And it was just like, I just wanted to do something else, but I love seeing what other people are doing now.
Right. And you mentioned you initially were using the badge for your Black Hat training, right?
Yeah. So the Black Hat training was a G-shaped circuit board. So that was a different one. That was just the inspiration for all of them. I was gonna say, like, that one, I hadn't done complicated cutouts on circuit boards before that, but I had used I had been using a circuit board fabricator for a few years at that point, called eTechNet, to do some of my other work. And I knew they had good capabilities. So I'm like, let's just see if this will work. Like, let's not do a square. Let's just see if we can do it, because my G logo is like not a very standard shape. And they were able to do it, and like it came out pretty cool. And I think that's when we realized, oh, we can do artwork on circuit boards too. and then, different solder mask colors and different things. And it really, like, there's a lot more that people can do now than the typical green square board that, previous generations of engineers and hackers had been stuck with.
Yeah, and the designs these days can look like really amazing, like instead of the green color. So when you move from like making badges for your or making hardware devices for your training to making badges for DEF CON, were there like any challenges involved in like scaling from like maybe like 20, 30 or 50 to like 6,000?
Yeah, so there's definitely a scale issue. My professional training is as a product designer, as a computer engineer. So when I was part of the Loft, we ended up selling the Loft to start a company called AtStake, which is one of the first computer security consulting firms back in 2000. Before then, and during the Loft, when I graduated from college, I was working at a product development company, working on medical devices and biomed stuff. So I had the actual experience of knowing how to go from prototype to production and visiting factories and seeing what they needed and test procedures. And it's a hard thing because building one or a handful of prototypes, you don't run into the issues that you do when you're at, thousands. Even as far as like, component tolerances and part sourcing and, delivery deadlines and shipping and customs and testing. All of these things end up kind of snowballing into like a big thing. So the dealing with quantity wasn't a surprise for us. It was dealing with shipping and Chinese customs was the surprise for us.
So the entire logistics here.
Yeah, the logistics, the supply chain and logistics ended up being a challenge. And because I'm so type A and like I like to have control of whatever I'm working on, even to this day, I still do this. When I'm working on production things and volume production, I bring all the parts into my office first, to my own lab, check them out, make sure they're right. That way I can, I know they're coming from legitimate distributors to hopefully cut down on counterfeits and problem parts. And then I'll ship those to the factory. So we did that with DEF CON for all the DEF CON badges. The issue is when we were sending parts to China, sometimes they got stuck in customs and they wouldn't release them to the factory. And then other times, the boards would be done and ready to ship back to DEF CON, and they would get stuck in customs for no reason because all the documentation was right. So we think there might have been, they were expecting some payoff or something, and that made a lot of people nervous for the first, I think it was DEF CON 14 actually was totally fine, but subsequent DEF CONs, there were times where we had to like overnight from China thousands of badges to get there for the first day of registration. Then we'd overnight Saturday delivery, the next batch for more, just like barely making it. So it's a hard process. I would say like if you're going to ramp up in production, try it with something sort of mid-range production first. Like don't go from 5 to 5,000 unless you have a lot of time to get all the wrinkles out of the process because there's a lot there. I think the other thing too is a lot of people nowadays, like, because of places you can order circuit boards without talking to a person, you can order assembly without talking to a person. There's all these different vendors, but the human contact is still really important, especially when you're dealing with huge volumes and a whole lot of money. And I think people miss that. So I was on the phone constantly with the factory. There was a handful of people that spoke English there, and they would translate for other people. The owner of the company actually is based in the U.S. He would fly over there to communicate with them. Even more recently on a project I was working on, I was emailing them every day to make sure they understood the test procedure. They would send me pictures of the result and sort of narrow down, the possible things that could go wrong. And I feel like we're losing that human connection. And if you don't do that, that's when you're going to run into major problems with manufacturing. Like you have to form relationships and you have to still deal with people.
Yeah, especially if you're planning to do something which is for long term, right?
Yes, exactly. Yeah, if you want it to last and you want it to be good quality, you have to make those relationships. And like with eTechNet, the factory that did the DEF CON badges, I've used them now for over, I guess, 18 years or something like that. It's like I can trust them, I can rely on them, and like those are the relationships that are worth building up. So you can always go back to the people that you trust.
Right. And on the same topic of building your own devices, so one of the most popular devices that you have built is probably the JTAGulator. which
And I
the
have one. I have one here on my desk.
yes, and it looks so awesome. Yeah.
You guys ready to JTAGulate? We're gonna have a we're gonna have a
So in the process of JTAGulating everything, so how did this idea come from to make your own device which can actually figure out JTAG pinouts and help in the entire exploitation?
Yeah, so sort of going back to my beginning passion of like building things and sharing things, the JTAGulator kind of came out of a need to kind of close this gap between finding a circuit board that has some test points on it or a connector or something, and then trying to exploit it with OpenOCD or other JTAG tools or something like that. Because we all, JTAG is such a huge Achilles heel of embedded systems, and currently it's still enabled on so many things. Even if it's disabled, there are workarounds and things you can do to still re-enable JTAG or take advantage of the capability that subset of JTAG has. So, but there was still this gap, and people that are coming from the software world, it's not as innate for them to look at a circuit board and go, oh, here's where I should connect. And so it came out of like doing my training class. In the presentation, I had this gap of like, here's how you can identify the interfaces on the board. You can take some voltage measurements to take a guess at what connections are what. You could maybe, look at the data sheet. If it's a BGA part, maybe you have to take the part off the board to trace things out or use X-ray. Like all of these things that are common reverse engineering things, but sometimes people don't want to do that. Sometimes they don't have the resources to do it. Or sometimes they don't have the skill to do it. So the JTAGulator was like this thing of just like, plug it in, type some commands, and let the tool try all the different possible permutations to see if there's an interface there or not. It's not foolproof, but it saves a lot of time for people that don't want to go through that main effort. And that's how it started. There had been some other work around doing JTAG pin finding and stuff like that. And so this is another great example of like building on that.
Right.
What I wanted I wanted something, if I was going to put my name on it, I would want something that I was going to use, because I'll only design stuff that I like and that I'm going to use myself, and that I'm interested in. So I wanted to have input protection. So if I'm connecting up to a device, I don't accidentally kill the device, and I don't accidentally kill the JTAGulator, or because it's connected through USB, kill my computer. So I wanted input protection. I wanted to use a parallax propeller processor, because I like using those. I like the guys at Parallax. I like their propeller. I've used it for some other stuff as well. A cool like 8-core processor. I wanted to have adjustable target voltage, so you could, like, if you're dealing with a mobile phone, you might be at 1.2 volts. If you're dealing with a router, it might be 3.3. So I wanted to add features that the other things didn't have, and that just sort of came about. So I made the made the first run. I made 100 of them for the release at Black Hat and DEF CON a few years ago. I think it was 5 years ago now. And I pretty much was like, all right, I'll get rid of the 100 and then I'll move on to another project. And it turns out that people are still buying them. I'm still doing firmware revisions for them. I have a whole bunch of firmware updates and bug fixes and feature things that I'm still adding, and my list just keeps getting longer and longer. But little by little, I'm rolling those out, and it's just ends up being a really cool kind of general purpose tool. But like with everything else, it's just a tool. It's like you have that, you have other things, you use what you need to use to kind of further your attack. I like it though. I'm super proud of it, and it's something where I know a lot of people have used it to kind of bridge that gap and find out what they need, and then they can use their software skills to go after a piece of hardware over JTAG. So it's been pretty cool when people are like, here's what I found with this. There's a guy on YouTube that had been posting, I don't even think I've ever met him. But he's been posting videos of finding JTAG interfaces on different hard drives and other things. Yeah. Sometimes it works, sometimes it doesn't, depending on the hardware design. But it's really cool. So yeah, it's just another tool to empower people and let people get involved in hardware hacking that maybe we're a little bit nervous about. I don't know what to do. I don't want to break it, so I don't want to touch it. So this is just helping people a little bit, get into it.
Yeah, exactly. People who are absolutely new to hardware hacking, or even don't know everything that is about JTAG and pin identification, they can simply get the JTAGulator, figure out which channels are connected, and find the pinouts. So while actually developing the product, what do you think was the most critical element in order to make JTAGulator such a huge success?
That's a great question. I don't know. it's
Like,
something like
yeah.
I I don't sell my own stuff, and people who have bought things, you know, that I've designed probably have noticed that. Like, I feel really weird about selling things personally. So what I'll do is I'll design products, and this is how, when I first started my company, when I left at Stakes back in 2002 and started my own thing, I was doing a lot of product development, consulting work, and then also licensing. So I would design a product and then license it to another company. They would manufacture it, they would sell it, they would get all the credit, and then I would get, you know, my name was on the board maybe or something, and then I would get a royalty from that. So I was sort of indirectly, I didn't have to sell stuff myself. And being an engineer, like I like dealing with people at conferences and friends that are, you know, technical, but I'm not a good customer service, you know, customer support person. And I just know that. So I'm not going to pretend that I am and try to sell my own stuff. So, you know, that's just sort of been a thing for me from the beginning of like not selling my own things. So I don't really know what ends up making a good product and why, you know, why the JTAGulator continues to sell and why, like, you know, some of the other products I've done have been great. Some of them have not been so great. It's just sort of, I don't know if I would say it's probably not marketing because I don't do much marketing. I think it's, you know, I hope it's kind of word of mouth of like people using it and then that helping them. But it also is probably the timing of IoT and hardware hacking becoming a bigger thing. And when this came out, I think it was 2013 was the first revision. You know, that's when people were starting to realize and get into hardware more. So maybe it was the timing of it. And again, there are other options of people. You can use an Arduino, you can use other platforms, but this is one I like to have this kind of single purpose tool that does what it needs to do, that's supported from the hardware perspective, from the firmware perspective, you know, that will implement bug fixes and try to do things. So it's just you know, maybe it's a combination of things. I'm not really sure, but it you know, definitely like, so Parallax sells this, they manufacture it and sell it. And they've been really great with the community of, you know, they're mostly in the educational robotics world, but they designed and manufactured some of the later DEF CON electronic badges. And they understand the need for good tools and to support engineers. And like, so it's really been awesome that they've been able to deal with the front end sales and support and distribution, which I wouldn't have been able to do on my own. Like, I wouldn't have been able to get it into distributors all over the world. And they did. You know, it's in your store, it's in Adafruit's store, it's in I think you can get them on DigiKey and Mouser and from their stuff, like all over the world. And like, I wouldn't know how to do that. So I think it's like a combination of things. And I'm, you know, and it's also going back to the relationship thing. Like, I've worked with Parallax for many, many years. I really trust them. I like what they do. You know, people say, oh, JTAGulator is so expensive, hardware is expensive, blah, blah. And it's like, yeah, but you have to pay for the parts, you have to pay for the assembly. They have to take, you know, they have to take a cut. They have to make money as they're manufacturing it. I make a little bit, not really. So it trickles down. It's like, I would rather make less money and get the product out to more people than try to do it myself and make more money, but, you know, per unit, but not get the reach. So I think it works, you know, works well for everybody.
Yeah, exactly. And I think like one of the other reasons which you might not have noticed, but might also be present over there, is that you wanted to build a tool which you can actually use being a hardware hacker, and something which really solves a problem. And that was the exact same problem which like maybe a lot of other people are facing.
Yeah, I think it might have just been that, you know, like, yeah, the fact that I was seeing that problem, it could have just been more people than I anticipated were also seeing that issue.
So moving from JTAGulator, so after that you have been working on a number of different products. So one of the tools that I want to discuss about over here is this new thing that you're working on, which is creating all the buzz everywhere around, called Optic Spy. So how exactly did Optic Spy come into existence?
So I also unfortunately don't have one here. My stuff is all over the place because I was just at a conference over the weekend with Optic Spy. So Optic Spy is a little device that is basically a simple light to digital converter. So it has a photodiode on the front that receives light, some amplifiers to amplify the signal, and then a comparator to determine what part of that signal should be a logic level 1 or a logic level 0. It's a tool that I've just been really fascinated with, kind of different things that can be used to either hack on a device or use as like some malicious purpose to exfiltrate data from a device or something. And, you know, we think about network, we think about debug interfaces.
Right.
And I was like, oh, well, LEDs are on every device. It would be cool to exfiltrate data through LEDs.
Yeah.
And there's been a whole bunch of work into data exfiltration using LEDs. There was a paper from 2002 that was sort of the seminal paper that demonstrated that some off-the-shelf products like modems and network devices and things, their status indicator LEDs, say like the transmit light on the product, was actually directly tied to the transmit line and sending the actual data that was being transmitted over the modem or over the network through the LED. It was just, that's how the LED would turn on and off. So if you had the right receiver, you could demodulate that and receive the data and decode it. So I just sort of been curious with that. I had another class that I teach on hardware espionage, so more of like the malicious, sneaky things that hardware can do. And for part of that class, I built a little optical receiver, and then into my G circuit board, a special mode that would send out a secret message through the LED. And that was just an exercise that students can build a receiver and kind of test it. I showed that to a friend of mine, Josh Lifton, who runs Crowd Supply, which is like a kind of crowdfunding. They do fulfillment and a whole bunch of other stuff, not just traditional crowdfunding. And he said, that's really cool. You should make that a little more user-friendly, like a little more accessible, not as a kit, but like a product, and we can use it at our conference, which is called Teardown, which is the one that I was just at this weekend. So it was sort of just by his request to turn my kit that I was using, in again, in like small quantities to small groups of people into an actual product. So it's something that has a USB interface you can plug in, which will power the board. It will show up as a virtual COM port on your computer, and you can basically, out of the box, you don't have to make any adjustments, though you can. You can kind of move it around and see, like, I need devices that have LEDs, like, are they transmitting information? What we did at Teardown, and there's a lot of demo code on my website now, is show how easy it is to create optical communications interfaces. So you have like an Arduino with an LED, or a Tomu device, which is what we use at Teardown. It's this tiny little USB. It's an STM32 microcontroller with LEDs on it. That's the size of the USB port. You just shove it into your USB port, and you can control that to send messages and do whatever else you want to write code for. So we use one of those to send messages. You could just hold it up and transmit. So really, it's just like another tool to inspire people and to get people thinking about, okay, maybe it's not just network. Maybe the system's leaking information through the light or whatever. Right. And it just, so for Teardown, it was great because we did a workshop where people got to just plug it in and it worked. They didn't have to build it or deal with any of that. What I did as another fun example, which is on my website, is it was I think a TP-Link router. I can't remember the actual number, but that had been hacked for a while. There'd been OpenWRT could be loaded on it. So I loaded, actually, I think it was DDWRT I put on it, and that gives you control of the GPIO pins, which are connected to the LEDs. So I ended up writing a little program that would exfiltrate the password file over the LED. And the LEDs, what's cool about this, and what's cool with Optic Spy is that if you're, depending on the modulation scheme you're using, if you're exfiltrating data or sending data over light, the light's blinking so fast that your eye can't see it. Right. And that's what's really cool. It's like, the webcam light on your computer, my computer there, it's like, maybe that's transmitting information. But for this router, I had the WAN light, which is normally going to be on anyway. Now it's just on, and you can't see it blinking, but it's exfiltrating, the password. So of course I needed administrator access to load the tool, but if somebody is skilled in software or network, compromises a device, loads a payload that can do that, then maybe there's some advantage. But it really is just like another project to have fun with and just be another kind of vector or entry point and whatever. And right. Whether it's security related or not, it's just like, I think it's just a cool thing.
Yeah, exactly.
LEDs like can send data,
Yeah, having like a whole different system, like super secret system to actually send and receive all the data. Yeah. And,
for sure.
Yep. So moving on. So in the recent times, like since you started like 15, 20 years back, so what kind of changes have you started seeing in the past 2-3 years, especially in terms of hardware security protections? And maybe like what are some of the unique or innovative ways in which you can actually bypass them?
Right. So I've seen like, I've been doing training for a long time, and I've been in industries and organizations, and sort of seen the progression of design sometimes getting better, I think because the resources are there for people to learn, I would like to think that the hardware is getting better. I'm not really sure it is. I think for the small percentage of hardware that's getting more secure, locking down, the obvious things, enabling code protection and removing debug ports and all of that stuff, then, the small percentage of those, you have all these other people coming in that aren't doing it right or basing it off of reference design. So I think, still with hardware, you don't need to jump through a lot of hoops to break it a lot of times. It's like if you can't get in through just general network misconfiguration stuff, there's, very common tricks that you can try to do from the hardware side as far as, forcing a system. If there's a boot process, like forcing the system to fail during the boot process to fall back into some other mode, a single user mode or something, administrator mode that you can hack on. Or, if you're just extracting firmware, you physically take the part off the board. So like there's all these things still that are so common and so easy that you don't need to create advanced attacks yet. Hopefully you will at some point, right? Where the bar is going to be raised enough where it's like, oh, now we actually have to work before we break a product. But I haven't really, the past few years, like I have seen more vendors starting to offer secure chips, and they'll say, we have hardware encryption, we have a secure boot process, which I think is a step in the right direction. But like we talked about right at the beginning, they're still too complicated for a normal engineer to implement. So it's sort of like, even though the features are there, it's too hard for somebody to do properly. A great example is the NXP, it used to be Freescale, NXP, and now I think it's Qualcomm i.MX6 series, I think, that had a high assurance boot. So it was like their secure boot process that they had some you could load in like an X.509 certificate and do all crazy advanced, complex, code signing, authentication, boot stuff. Some researchers had found some vulnerabilities in the way that the certificate was being parsed, and some other vulnerabilities as well. That and all that parsing code was done in boot ROM, so in mask ROM on the chip that couldn't be fixed. You couldn't flash update it. You couldn't do anything. So they found vulnerabilities that would exploit, secure boot on probably one of the best designed or most, intentionally designed security features they broke. And you can only fix it with a silicon revision, which is a lot of money. So even companies that are trying to do it right, the chip vendors, these huge chip vendors that are trying to do security right, still end up with problems. And that's, from our perspective, it's sort of fascinating and cool because there's always going to be something to break. But from like a user perspective or like a security perspective, maybe that's not a huge impact. It depends on what the product is in. But there's always going to be something to break. So I think, vendors maybe are starting to pay more attention because hardware is becoming more accepted and more talked about and more people are getting into it. But yeah, we still have a long way to go for sure.
Yeah, definitely. And yeah, it's at least good, like people are actually getting to know that they should be working on security and started taking steps in the right direction. Yeah. So before moving to the next question, for the attendees over here, if you have any questions to ask Joe, feel free to drop it in the question section below or in the chat section below. So one of the final things that I wanted to ask is, what are some of the tips what are some of the tips or the directions that you would give for anyone who is currently starting out in hardware security? And especially like, even though security is quite mainstream now, there are not a lot of resources on hardware hacking and how people can get started. So yeah, what kind of actionable tips would you suggest?
I would first say, don't get discouraged. There's so much work out there and there's so much that people have done. And don't get discouraged by that. Like just because it seems like everything's been done, there's always going to be something new. I would also say, like, build upon other people's work. Again, that's how I got started. I was building things out of magazines. So you can go to, go to Hackaday, go to whatever other website that talks about interesting hardware hacking things. Find a product that already has been hacked, replicate that work, and then start building from that. And like that's fun because you learn from it, but then you also realize a lot of hardware hacking and most hacking in general, like it's not black magic, right? It's just it's just a different set of skills. And once you realize that, it's like so empowering to do something, and then you can build on it. So don't be discouraged and don't be afraid of somebody, scouting your work, or if you do something publicly, like what somebody's going to say, like that. I feel like with the InfoSec community and really the internet culture as a whole, where everybody is just like, you know, trolling, and you only see all the negative stuff, you never see the positive side. Like, you really just can't listen to anything. Like, it's very hard for me not to read comments, and I don't read comments. I rarely, you know, get into conversations on Twitter. It's just, I don't want to go down this rabbit hole of ultimately, like, you know, possibly hurting somebody else's feelings or making somebody not want to do something. So I think it's like, ignore that stuff, you know, ignore that and just do what you want to do and learn from it. And if somebody says it's lame, you know, I would even push them back and say, okay, show me what you've done. Show me something better. You know, like if somebody complains about a product of mine, it's like, all right, it's open source. Go modify it, make it better, contribute to the code base, do what you want to do. But I think it's like, ignore the negativity, do what you want to do, build upon existing work, read old presentations, watch old presentations, come to conferences, you know, do a little talk at a smaller conference, maybe like a lightning talk, and meet people, and then like you build up your confidence to do larger things, or you go and do a workshop somewhere. There's so many resources now, and I think there's a lot of supportive people. It's just finding the supportive people usually happen in person, and then you have the negative energy on the internet. So it's like, you know, kind of dealing with both of those. But it's a great field to get into. There's plenty to do, whether you want to, you know, do security design of products or breaking products. Like, there's so much to do. So it's a great field. Tons of resources, tons of great people. You know, I have a lot of fun at conferences, meeting people, and it's generally a very welcoming community in person. So yeah, I would say, you know, don't be afraid and just start doing it.
Yeah, that is like spot on. Yeah, you have to actually eliminate all the noise that is out there and focus on what you want to do. So we have got a couple of questions over here, and before this, yeah, one of the questions which a lot of people wanted to know about is the Discovery Show. So how did all of this happen? Like,
yeah, we're here. It's D-Day for the personal airbag. Finally, we get to put everything together, the electronics, the airbag system, and see what happens.
I don't want to overstate the case, but it, you know, could resemble a life or death situation.
Sure, I forgot about that. So from 2007 to 2008, we filmed a TV show called Prototype This, which was on Discovery Channel. It was 4 engineers building crazy prototypes of projects. And it was a great experience to share the engineering passion, my engineering passion, with the entire world. And it was something like a really great experience. That ended up happening. It's on DVD now. I think it's still airing around the world in some places. You can get DVD on eBay. You might be able to see it on Netflix. Pretty sure it's on the Pirate Bay. And, you know, I would say get it any way you can, because I don't care. I want people to watch it.
yeah, and the projects are like actually crazy, right?
The projects are crazy, yeah. So we built some examples. We built a 30-foot tall water slide simulator. So it was a giant donut made of water slide material that had hydraulic motors and wheels and encoders, and we would spin this wheel, this donut we called it, and you would sit in the donut in a inner tube that had water in it, and we'd project an image of a water slide, and you would be in a water slide simulator. The thing would move, and you could do like a 3-minute water slide ride, which was ridiculous. It's like a lot of the stuff we did. The tagline for the show was inventing the future or something like that. And some of the stuff we did was pretty silly like that. We had 10-foot giant boxing robots that would move based on the players of movements outside the ring, which was based on Rock'em Sock'em Robots, like the game. And then the rumor is that the movie Real Steel that came out a few years later was based on that episode of Prototype This. We did some useful things, like we did a firefighter rescue. We had a stair climbing robot that you could like push up the stairs. It would climb for you. We had a firefighter pack, a high-tech firefighter pack that had like a heads-up display, and all sorts of interesting ways that would help firefighters. Like we got to actually meet with firefighters and do their training, and then they got to test our stuff. We did a life-saving drone. So it was a drone that would, launch off of a platform and then deliver a life jacket to somebody in distress. We did a pizza delivery drone. or pizza delivery robot that would drive through the city and deliver pizza. So some of those things, which were sort of silly at the beginning, ended up actually like now there's products that are doing that. So there is a life-saving drone. The Google self-driving car that we use for part of the pizza delivery episode, but actually it wasn't even the Google self-driving car yet. It was just a project that a guy that was working at Google, Anthony Lewandowski, was working on. Apparently the guys from Google, Sergey and Larry, saw that episode of Prototype This and said, hey, you should do this full time for Google. And that became the Google self-driving car. That then became, you know, all of the autonomous vehicle stuff. So we always joke that, like, you know, he made out way better than we did on the show because he got a job out of it that he could, you know, work at Google and design giant robots. But the way that show started is I was, or at least the concept had been around for about a year or two in advance, I think, building up sort of what they wanted to do. They reached out to Make Magazine, sort of the production company, as they were trying to figure out what people they needed. And I was an advisor for Make Magazine when it just started as far as like this hobbyist, you know, building maker magazine. And they said, the production company was like, well, we need an electronics guy because they already had casted Zaz as the software robot guy, Terry as the machinist, and then Mike North as the materials guy. So those three decided they needed an electronics guy, which they were right. And the production company reached out to Make Magazine. I think they spammed a bunch of email lists and everything, engineering lists. And Make said, you should talk to Joe. So I met with them in San Francisco. I was not living in San Francisco at the time, but I was up there for a conference and did a little dog and pony show, brought a bunch of electronic projects to them. And then they're like, okay, great. They were filming, you know, they filmed a whole bunch of different people. They're like, great, we'll get back to you in a little while. I then went on a solo bike trip. I went just riding down the California coast on a bike by myself. I had a phone, but it was like a prepaid phone. Like it was, you know, I don't even think people had real Blackberries at the time like that. They were actually using them outside of like businesses. So I was sort of disconnected from the world. And I get home from the trip and there's like all these voicemails and like, we want you on the show. Can you come tomorrow to film the pilot? And like, that's just how TV was. It was like this hurry up and wait sort of thing of like, okay, we want you. And then there's nothing. And then all of a sudden it's like, you have to be here tomorrow to start. So we ended up moving to San Francisco and doing it. And it was a great experience. And it's actually something that I've been thinking about doing again, like trying to do some sort of STEM-based TV show. I started writing a little proposal for a show that isn't exactly a build show, but it's something like I got inspired by some a little field trip I did with my kids, and realized that, you know, like Prototype This was targeted to ages 18 to 39. It was the Mythbusters audience because it was produced by the same company as Mythbusters, Beyond Productions. But it turns out that we inspired a lot more of younger engineers and younger people who wanted to be engineers. And I thought that was really empowering of like, instead of speaking to your peers, it's like you can really get younger people excited about engineering and electronics. So I have this new show concept that I want to do that I've been writing up. I need to pitch it to a few people and see, but it would be fun to sort of get back into that world. Even though it was really hard and frustrating to do filming, and I've given talks about the process of the show. And I think if you search online, there's a lot of gripes about how hard it is to be like an engineer and a TV host at the same time. But the end result is like pretty powerful, and you can reach people that aren't on our same forums that we deal with, right? So yeah, maybe I'll get back into it if I get lucky enough to find the right people and find the right interest.
Yeah, and yeah, good luck for that. And yeah, what's better than inspiring a whole new generation getting into hardware hacking? Before wrapping up, so there are a couple of questions over here. So one is, I'm a websec analyst. Do I need to study in-depth electronic stuff to get started into hardware hacking? So what's your suggestion? Like how much should be the balance of digging deep into it before doing hacking?
Yeah, so like how much actual electronics or engineering background do you need to get into hardware hacking? I would say, like, I think people have different perspectives. So, you know, some people I know are like, well, you don't need any because embedded systems now, IoT devices are basically just small computers running specialized code. So in theory, if you're not doing any physical hardware tampering, you don't need any hardware experience. Because I come from a hardware background and I really think physical hardware is really interesting, I would say like just having a general understanding of what components do what, you know, what what things are connected, how circuit boards are designed. There's a
Right.
book called Electronics for Inventors.
Mhm.
That's a really good book. That's just like a very kind of cursory view of electronics. So like having something like that as a resource is great. You don't need to go to engineering school to do it.
Right.
And I think the more you maybe you start at a high level doing software style attacks on hardware, and then you go layer by layer deeper, and that all of a sudden you're at the circuit board level and you're looking at test points and you're looking at interfaces, and then
Yep.
you'll just learn as you go. So I think if you have a basic knowledge to start with, and then as you go you'll get deeper into what you need to
Yep.
do.
Yeah, like start learn things as you perform them, right?
Yeah, and that's it. Like people always, like you should always want to constantly learn anyway. Like nobody's
Yeah.
an expert, and like I still feel like a lot of the stuff I do, I still feel like there's tons of stuff to learn, and there is. Like that's what makes engineering and what makes hacking so great. And if you think you know it all, then you should probably not be involved in the field anymore, right? Because like there's just so much to learn.
Yeah, exactly. There is another question asking, are there any standards or methodology guidelines for hardware hacking? Like, is there any accepted standards?
Any standards as far as the process of doing it or the process of securing yourself?
I think the process of doing that.
Yeah. Not really. I think everybody has their own kind of process of how they like to go through things. So like in my hardware hacking training class that I teach, it's more of a rigid process because that's my engineering background speaking. So I always start a certain way and I, do my information gathering about the product. And then I try to take the product apart. I get access to the circuit board. I look at the components. I see how they're connected. I look for debug interfaces. Right. I get firmware and go layer by layer, which isn't always necessary all the time. But some people might just go straight for the network side and see how the device is communicating over the network and using Wireshark or grabbing the firmware packages, doing software style attacks. Right. So there is, as far as I know, there's no like documented, process. And I think it just varies, and you end up making your own. Like you learn, if you watch talks from other people's process, that you can sort of, form your own process that makes the most sense to you.
Yeah, exactly. Yeah, that makes complete sense. Yeah. And one of the other questions is, are there any books for starters? I know that you have written 3 books, right?
Yeah, I would say the first book that always comes to mind is called Hacking the Xbox by Bonnie Wang. And that is an amazing book because first of all, he's a great writer. And he's been in the community for a really long time. We've worked together on some projects back in the day. And just saw him over the weekend at Teardown, which is pretty cool. He lives in Singapore now. But this book kind of chronicles his process of hacking the Xbox, but it talks about the different kind of hardware hacking steps he went through. So it's a good, it's a very detailed dive into the Xbox, but it talks about lots of other things as well. That book is available for free now also. So you can get the physical copy from No Starch, but you can also get a PDF version. So I think hacking the Xbox is great. I'm not going to plug the books I wrote because it was a long time ago and they're mostly obsolete, but there are two books I wrote: Hardware Hacking, Have Fun While Voiding Your Warranty, and Game Console Hacking. The projects that we discussed there, that was like 2005, I think, 2006. So the projects are mostly going to be obsolete, but you could still learn some stuff from it. But I think Hacking the Xbox, you start there and then maybe, see what he references and see what books other people reference in their presentations and stuff.
Yeah, perfect. And I think Bunny has written another book recently, right? Getting the guide to manufacturing your hardware in China.
So he has that one, the one about manufacturing in China. But then there's another one that also came out called The Hardware Hacker. That is sort of like a compilation of a lot of his blog posts talking about hardware hacking stuff.
Right.
So you could read his website or you could get the book. But it's a really, really neat, well-written book.
Yeah, perfect. So there's another question. Hi, Joe. You mentioned some updates coming for the JTAGulator is one of those open OCD integration.
I get a lot of emails about that. I actually just got an email about that yesterday. So integration with OpenOCD, basically what I'm calling like a JTAG pass-through mode, is high up on the list. I would love to get it done. Basically, the concept would be, with the JTAGulator, you have to plug into the test point. You would run your commands to identify the interface. But currently, you then have to unplug the JTAGulator, plug in your JTAG hardware tools, whether it's an FT232, whether it's a Bus Pirate or whatever, Bus Blaster or whatever it is. So the JTAGulator pass-through mode would let you then use the JTAGulator as the hardware interface to OpenOCD. And also UR-JTAG, I think would be cool. So I guess the answer is, I don't know when. It's high up on the list. I really want to do it. There's a few other things that I've been trying to get done. Somebody actually like 2 years ago submitted some code to let the JTAGulator be a logic analyzer with SIGROC, so the SUMP interface, SUMP protocol. I'm going to put that in. There's some other code that I just need to roll in, some bug fixes. There's still sort of some detection reliability issues with some devices, and that is sometimes I think based on the way that the target hardware is designed, with the pull-up resistor, things interfering and causing my circuitry to not detect those interfaces. But I think some of it might be some firmware bugs. So there's some of that stuff that I want to kind of finish up and at least get those as good as I can out of the way. And then OpenOCD would be one. Single wire or serial wire debug. There's a bunch of other ones. It is an open source project. But the problem that I found is that because it's in SPIN, it's not in C or like a standard language that most people know. It's in SPIN, which is a propeller-specific high-level language. That's sort of like C. It's sort of like Pascal, but there's a learning curve there. So I don't have this expectation that I expect people to write code for the JTAGulator because it's not an easy thing to do. So it has sort of fallen a lot of times on me and a few other colleagues that have contributed some stuff. Which is why it's taken so long just to do simple bug fixes and other things. But yes, I guess the answer is I really want to do it. I think it is technically possible. And if it is, hopefully I will eventually get there. I just don't know when.
Yeah, and I would highly recommend, like, anyone watching should learn and maybe contribute.
That'd be amazing.
Yeah. Okay, so I think we are running out of time. So there's one last question. I think we can answer that, send it as an additional resource to everyone. So it's like Joe's recommendations on the websites or blogs you can follow. So I think, we can send it out as an email so that everyone can have that entire list to get started. So yeah, thanks again, Joe, for doing this. Thanks for the time, and really appreciate you sharing all the knowledge and your contribution to the entire society.
Yeah, well, thank you for having me. Thanks everybody for spending time with us and listening to this. And yeah, hopefully something interesting and exciting came from it.
Yeah, and good luck hardware hacking, everyone. Thanks a lot.
Yeah.
Bye.
See ya.